Alright, so now that we've been working with logarithms for a while, we're going to use some properties. So we're going to learn some properties so that we can then later go on to solve equations that involve multiple logarithms. So first thing we need to do is notice we're doing properties. So again, we're doing properties of logarithms. Our objectives are going to be to simplify logarithmic expressions. What that means is that we're going to write one expression as a single log, or we're going to take those and expand them to do sum or difference, as we're talking about, and determine if things are equivalent. You'll see this more in your homework problems. So this is going to be more like homework in class. Alright, so let's start off with our first thing. Just like we had rules with combining exponents, we have rules to combining logarithms. So our first property is actually two things. We have inverse properties. It says if you have a log, so if we take the log of something base A of A raised to the x power, all that is going to equal is it's going to become x. And that is because if you break it down here, we do a to what power gives us a to the x. Well, the x's need to match. So then that's how we got our good old x. Your second one is that if we take a to some power of a logarithm with that same base a of x, then the log and the a are going to cancel out to just give you x again. So again, inverse properties, it's telling us that if we have two matching things, we're just going to have what's left. And this is explained down here where we have a to log a. Well, a log base a, if we change this, log base a of what, is going to be equal to log base a of x. So remember, a logarithm is an exponent, that type of thing. So that's where we get x from. So, trying these two examples here. Oh, that should not be there. You have log base 5, so the 5 here of 5 to the 7th power is going to end up giving you just the 7. Same thing here. E, natural log, well that's base e, so the e's match, so that gives you the 4 here. Now, you were going to try these two, but apparently I put them down here for you. So again, 8, we see 8 matches. We're left with the 15. So that's where our 15 comes from. Same thing here. Natural log has a base e. E matches with e. We got 15. That's where we got our inverse property from. You will see this more when we're going to use multiple logs. All right. The product rule. So this is where things get a little bit more complicated. The product rule says if you have a logarithm of base a of m times n, that can equal the log same base a of m added to log base a of n. So basically, multiplication becomes addition. Addition will become multiplication. So first thing to notice here, bases must be the same to apply the rule. Another thing to notice here is just like exponents, multiplication and addition are paired together. So multiplication and addition are together. And what I mean by this is if you had x to the 3rd times x to the 5th, well, you would take x to the 5th plus that to equal x to the 8th. So that's what I'm talking about. Multiplication and addition are paired together. The rule works for combining and separating logs. So combining, we're going to go ahead and multiply for separating, we're going to become and turn into addition. This will make more sense when we do these examples right here. So 2 logs separated by addition, so that looks like log base a of m plus log base a of n. So addition means that we multiply the insides. So log base 4 of 15 times 5, which then becomes log base 4 of 75. And that's your answer. Again, if we have it already together, notice that in here there's some multiplication. So that turns into expand with addition. So I'm going to expand this by pulling it apart to log base 3 of 3 plus log base 3 of x. Well, now you should realize your inverse property here, this part, knocks each other out, 3 and 3, again going inverse, that becomes just 1, because the exponent here is 1. So 1 plus log 3 of x. Alright, these 2 examples here, those are you try problems. You give it a shot. Let's move on to the next set, the quotient rule. So we've got product rule, we've got inverses, now we've got the quotient rule. So this states if I have a log base a of a quotient, so m divided by n. Well, just like exponents, you should see that this is actually going to become log base a of m, and we're going to subtract log base a of n. So once again, bases must be the same. Just like exponents, as I measured, division and subtraction are paired together. Of course, I'm going to give you an example here. So if we're doing x to the 12th over x to the 4th, well, you're going to actually take this and you're going to subtract here. So we're going to get 12 minus 4 gives me x to the 8th power. So again, that's how they relate to that. Combining and separating, when we combine 2 logs, we're going to go ahead and divide. When we separate logs, think separate, we are going to subtract. So first example, already separated, we want to combine. Subtraction tells me that I need to do division. So combine, go to division. So I need the natural log of 10 divided by 5, which is the natural log of 2. Again, these are separated, so we need to combine. Combine means divide. So I need log base 3 x squared minus 4x minus 12 divided by x minus 6. Now I hope that some of you are like, well, can I factor that top part? You sure can. It should become log base 3. Well, I need 2 numbers to multiply to 12, add to get negative 4. Well, shouldn't we try to use x minus 6? Probably. So let's try x minus 6. Well, 6 times 2, but I want a positive 2 over x minus 6. So then your x minus 6's go away, and you're left with log base 3 of x plus 2. Now this is your final answer because we cannot pull apart addition. So you cannot pull that apart. Alright? And here we're already together, so we need to separate, which means we need to use subtraction. So I need log base 4 of what's on top, x minus the bottom. So log base 4 of 2. Alright, so one more rule, and then we're going to do some expanding and contracting, which we've already been doing. So the power rule. The power rule states that if you have a logarithm base a of some number raised to a power n, then you can take that power and make it into n times the logarithm a of that n. So basically a power just comes and it swings on down in front. That's all the power rule is saying. Or I can take the power and I can put it back up. So if an exponent inside of a log, you can pull out an exponent out front by multiplying the remainder. So you can pull out front and multiply by log. So the remaining logarithm. This helps to simplify. We'll use it a lot actually to simplify. If there's a multiple already out front, so already, then you can put as an exponent in the log. So this is also, again, just like exponents, where you have a power to a power. So your example here is if you have x to the third times 7, well, we're going to multiply those together, so that gives you x to the 21st. So pulling it out, you can put it in here, or you can pull the 7 out, because both of those are equivalent. So our examples here, we're starting with a power on the inside, so my power is here. I can take the power and put it out front. 2 times the logarithm 5 of 4. Alright? And then I'm going to go ahead and leave this one for you to try. So you try. This one's a little bit tricky. Remember that a square root really is the same thing as the 1/3 power. So this is log base 10, really, of 5 to the 1/3 power. So again, I can take that power 1/3 and put it down front. So 1/3 times log of 5 is left. Alright, and this one, you bet, is also going to be a good old you try problem. Alright, and before we finish up here, we need to talk about some expanding and contracting. So, expanding a log. Now we're going to put all the properties together. So, look at this. This is a single one. I need it to be multiple. So here, I have multiplication, which means that I need to add. Here, I have division, which means I need to subtract. So let's start with the multiplication first. So log multiply x, I need to pull it apart as addition, plus log z, because I multiply them back together. Well, I had division. Well, what am I dividing by? Y. So subtract, again, log of y. And I've pulled that apart. Alright, so now, again, looking at the next one, there's a lot of multiplication here. There's 2, actually. So multiply tells me to add logs. And then, hopefully, in here, you caught the power too. There's a power, so we need to deal with that later. So first, let's pull apart by adding. Natural log of 3 plus natural log of x plus natural log of y cubed. And again, take that power it's just going to come down front. So now we have the natural log of 3 plus the natural log of x plus 3 natural log of y. Alright, and now we got one more example before we condense. So again, you've got multiplying here. So that means I need to add some logarithms together. And that seems to be the only thing that's happening. So I've got log 3 of 9 plus log of x. Don't forget base 3. This is a little bit tricky. 9 is really 3 squared. If you can rewrite something with the same base, you should try. So log 3, well, that's your inverse property here. So that actually, again, the 2 comes down here, and I'm left with 2. Well, nothing happens to that log 3x, so log 3 of x. So you do need to realize sometimes you can pull apart those numbers. Alright, let's quickly try to wrap up the condensing, and then you'll be on your way. So condensing, that just means we need a single logarithm. Well, there's 2 here. 1, I see this out front, so that's a power. It becomes the 1/2 here. I see subtraction, so that means I need to turn that into division. So first, log x. Well, I know I need log of x to the 1/2. I'm dividing by what? X plus 1. So x plus 1. Finally, let's just rewrite it in a clean way. Log 1/2 is the same thing as the square root of x over x plus 1. And that's the much more clean way to write it. Alright, and again, condensing, all you're doing is working backwards. So I see this 3 out front, that tells me put it up as a power. I see a 1/2 out front, again, put it up as a power. There's nothing there. The subtraction tells me I need to divide. And the addition, which I kind of hid in here, tells me I need to multiply. So let's first rewrite this with the powers up. So log 5 of y cubed plus log 5 of, I'm going to put square root z, and minus log 5 of x. No power there. Alright, multiplying. What am I multiplying? Those. So I need log 5, got y cubed, square root z. Subtract, or divide, what am I dividing by? X. So divided by x. And then that is your final answer. And you probably guessed it, I'm going to leave this last one here for you to try. So you try that, bring it to class tomorrow, and we will talk about these properties.